welcome to Astronomy for Beginners. Obviously for the recent last guides I went through, and I hope you've learned a lot, and it should give you a good start in astronomy. Right, today's guide I'm going to go for something a little bit different, and this guide what I'm doing is astro-photography. Now astro-photography is can be a bit complicated and it can be brain taxing, and it's basically a completely different topic all on its own. And a lot of astronomers who start out in astrophotography, it can be a big steep learning curve. However, like for most of us, we're not always photographers and astronomers to a certain degree. We don't know much about, but a lot of the times I've learned through people's experience on using a certain amount of equipment and stuff. I mean, to begin with, when I first started out, I was just a visual astronomer, and I just used my telescopes just to do visual work. But then I found out about astrophotography, and there was one example where one guy set up his telescope setup, alright, and he had a little Maxutov, and he basically set up a camera and he took pictures of Jupiter, for example. And I thought to myself, wow, if it's that easy to do, I could do that, you know what I mean? However, I'm going to today's guide, I'm going to basically show you a rough sort of setup of particular items for certain examples, you know, and how you could use your telescope for astrophotography. Now there is two types of astrophotography. One of them is lunar or planetary astrophotography, and the second one is deep sky photography. Now these particular two subjects vary in certain degrees of sort of amount of knowledge you need to know, and both of them demand a certain amount of equipment to be used. As I was saying before, alright, astrophotography can be easy or it can be complex. Now for beginners who want to start out, alright, start off the basics first, and I'll show you the example from behind. Alright, a typical setup that I use, alright, and the best start is basically start off, if you want to start astrophotography, start on something like the moon, for example. The moon is probably the easiest object you could use, you know, to image or take photos. You know, it's quite bright, it's easy to find, and the results you get from it is, well, quite spectacular, to be honest with you. And once you've got an image, alright, of that particular object, like the moon itself, you will be thrilled. I guarantee it. The first image, no matter what sort of quality, disregard what other people say in different forums, or oh, you could have done this, or oh, you could have improved on that. Yeah. But the main key is, no matter what image you got an image of something like the moon, for example, first time ever, and you achieved that. That is your image, and you created it, and what a feeling. Now that's the sort of feeling that I'm trying to get to you guys. When you first start astrophotography, and you manage to get a result, that result of getting an actual image of the moon. And the moon is where it all starts, and then as time goes by and you start getting into this subject in astrophotography, that's when it's really addictive, and sooner or later you will progress even further. And bear in mind, you know, the moon is an easy object to image or take photos, but as time goes by it will get difficult, and it just depends, you know, what equipment you have and what you're using, what telescope you're using. So what I'm going to do is I'm going to show you a basic setup to begin with for the moon and the planets, alright, and I'm going to give you like a little guided tour around the equipment I use, alright, to give you a sort of a general idea what you can do, alright, with your setup. And like I say, not everyone will have this sort of equipment, but believe it or not, I mean, just taking the pictures of the moon itself, you know, you can just get your, if you've got an iPad or you've got an iPhone or something like that, and it's got a built-in camera, you can actually physically take a picture of the moon directly through the eyepiece and take an image on there. Now that's called digiscoping. That's one method of imaging. But I'm going to show you my method, alright, and it is achievable. One thing I do need to highlight to a lot of beginners: astro-photography can be a very expensive hobby to get into. Now, ignore people trying to say you need to spend £1,000 on this, £5,000 on that, you need this equipment and all that. It's wrong to us, yeah? You can achieve absolutely stunning results through basic equipment on a budget and successfully get some really good images, alright? Ignore people trying to influence this and that, saying you want that and so forth, right? Ignore that for the time being, alright? The only time people suggest such amount of equipment is, yeah, that's really for deep sky objects where you need more complex equipment to operate things like that and get good images of deep sky objects. But I'll cover that in the later guide to show you a basic setup of deep sky imaging. One thing I do need to highlight is the only problem with my setup is I don't have a DSLR setup. Now a lot of guys who have got a DSLR camera, you can actually use it for that. But what I'm going to do is I'm going to show you an example of what I use for planetary and lunar imaging. Okay, this is going to be the easiest starting point for beginners, particularly like yourselves. Alright, if you've never done astrophotography, start on the basics, like the moon. Alright, seriously, start on the basics, because the more you jump into it, you end up spending probably more equipment than you should. Alright, and it's not always the case. And if you spend too much on particular equipment that you don't need, or equipment that you don't know how to use, or even equipment that not even work with the telescope. So, general idea is start off with the basics first. Now there's a lot of books out there, alright, a lot of good books out there, and a lot of good sources on the internet as well. They also provide some sort of good general information as well. But I'm going to show you my setup, see what you think, and like I say, any questions, feel free to ask me on Astronomy for Beginners and see what I can do. Best what I can do is help you onwards. So we're going to take a look now of my setup. Okay, I've got my my Lunt, my 80mm ED refractor. As I said before, I've got the telescope working, go to, it's polar aligned, balanced and so forth, and assuming that it's tracking. Now I'm looking at the moment at Saturn, for example. Right, my basic setup, if I want to image Saturn in particular, I do a lot of my imaging by aphotical imaging. And basically I attach a camera or something through the eyepiece. Right, there's no lenses, and I usually, if you're doing DSLR and all that, you detach the lens itself and you attach it by. Now, however, I use a webcam. Now, webcams, believe it or not, are probably the best start for lunar and planetary work, without a doubt. A webcam like this, for example, this is a Philips SPC 900. Now this is quite an old camera. It's a 1.3 megapixel camera and does about 640 to 480 pixels sort of size. It's just a normal webcam. Obviously this is slightly modified because it's cooled and all that to do other things, but basically you can just use a normal webcam. This is basically a normal webcam, alright, and the only difference is that with most webcams, usually you can attach this to the telescope. Now it might, you can use any sort of webcam, alright, and it will plug in straight into a USB port just like that onto a normal netbook. Alright, this netbook works perfectly for imaging, and believe it or not, I actually use this netbook. It's an iZeus laptop. It's only a 1.6 megahertz processor and a gig of RAM. Alright, and it runs, believe it or not, all my cameras, including my my Deep Sky CCD QHY 8L, without no problems. And it can even run the guide scope as well, and all my software runs on with this laptop alone. Alright, £200 this cost me, and you can probably pick one up second hand for probably about 100 quid or something like that. Dead cheap, and does everything for me. It's a good capturing laptop or netbook. However, when you want to do processing and all that, then I would not seriously go for something as small as this. Now, as I mentioned before, with a lot of webcams, usually depending on certain models, webcams can fit on onto a telescope. Now, usually what happens is you can buy these adapters. They're called webcam adapters, and basically you get a certain model, and this is an inch and a quarter barrel, and basically what you do is you unscrew the actual lens on the webcam, take that out, and then you screw this adapter into the webcam itself. Now you can usually pick these adapters up for usually about £10 to £12. Alright, and that's all you need really, and you're ready to go. Bear in mind, I use an infrared filter on this, because basically it helps to boost the contrast and all that. But you don't have to get one of these, but they're handy to have, these little IR filters, and they do increase your views a little bit better. So whatever you're imaging or capturing the images, you get better results. Plus, it serves a really good dust cover which protects the chip itself, and you can see the chip in there. Alright, and it stops the dust and all that getting in there. And basically, this is just normal webcam. Alright, and it basically, once your USB is connected up, alright, and basically, what this does is, as you see here, it slides onto there with that adapter, and then it screws on there like so. Okay, and then what happens is as the telescope's already set and it's tracking Saturn, for example, alright, the software that I use on the laptop is SharpCap. Now SharpCap is downloadable online, and you can use that, and you can use that as a free imaging software capturing program. Alright, and SharpCap will allow you to capture the images. Now, obviously, when the setup's running, ideally when you're using software, you look at the live image, alright, and the first thing you want to do is, once you've got something in there, it will be blurred. I guarantee it will be blurred. And what happens is that you need to focus the image. So you back and forth the focuser, and as you get to a point, as you see on the screen on the laptop, for example, and you look on there, as soon as you get a sharp image and you start to see obviously the structure on Saturn and all that, for example, you're in focus. But if it's a blur and it's not working very well, just keep focusing it until you get sharper. Now, there's one thing that I need is, if you can't get into any focus, and say you fall out like so and it's not focusing at all, there may be something with the imaging train. Basically, on refractors, if there's not enough focus, outward focus, you basically need to buy an extension tube and to extend it, and then should go into focus. But however, for this refractor, there's no need for this, because basically it'll go into focus around about there, sort of thing. It just depends on the telescope you have. Alright, now not a lot on the 127 Max, and a lot of the refractors usually go into focus anyway with webcams. Right, as I mentioned about lunar and planetary imaging, planets in particular are very small. And the problem is, if you're going to use a webcam and all that, because of the chip size being small, you can only get a small disc and all that. So the thing is, the ideal thing about planetary imaging is that you need to get that image scale up so that you can see the finer details on the planets and all. So basically you want to make that image closer. Now the thing with the planetary imaging is you need to extend the photical length, to get that image scale up. Now there's one way you can do it, as I mentioned before, is you can use a normal webcam, and this is where this adapter comes in handy. Alright, and I mean, here is your webcam, alright, and this is the adapter where it comes in handy. And to get the image scale up, now on a telescope like this, it goes up to about f7. Now for planets and all that, ideally you want to be looking at f15 to f25 or f30. Alright, so basically you need to extend that photical length to get that image scale. And to get some really good close-ups of the planets, there's one way you can do it, is use one of these. Now this is a Barlow lens. Now all that is a lens that will increase the photical length of your telescope, and then what you do is you attach it to the webcam. Alright, attach it to the webcam. Okay, as simple as that. And then what you do is you slide the camera into the main tube, and there you go. What you're doing now, you effectively now increase that f7 to an f14. That is a 2x Barlow, so it's an f14 telescope. And what that does is it will make the image, say like I'm imaging Saturn, will make that twice as big. So basically you start to see hidden detail and all that. Bear in mind is the more magnification you use to increase that image scale, the more it deteriorates. Now it depends on every night. Every night is different. And like I say, if you've got unsteady nights where the stars start to twinkle and all that, it basically means that you've got bad turbulence. So like I say, the more you increase that the magnification up to get that image scale up to see the close-ups of the planets, you start to see more of that turbulence. However, if you're stacking and you're using a sharp cap and you want to stack the images, alright, you're going to get turbulence. But if you've got an image, a picture, a certain part of the film where it's clear, you can stack it and then give you a much sharper image. But it just depends from night to night if you can boost that magnification up. Now usually a 2x Barlow is usually what you need, but for some telescopes like reflectors, which have a shorter photical length, you need to start investing on bigger Barlow lenses, 3x, maybe 4x, or even 5x, depending on what sort of image scale you want. But a 2x or 3x Barlow will give you the sort of image scale you need for close-ups of the planets and that. And also for the moon as well, if you want to see some close-ups of the moon's detail on the craters and the mountains and all that, really good close-ups of that, you can use that Barlow to do great shots from there as well. Alright, I think it was an idea to show you this idea, because a lot of people were wondering how can you get close-ups of the planets and the moon, and this is the method how you can achieve it. One disadvantage of using this method is because you're increasing the focal length for lunar and planets, is what you basically were doing is you're narrowing that field of view. So for as you're looking it through your laptop and the image appears to move out really quickly, it usually tells you that it might be because the narrow field of view has been narrowed to an extent. Also, when you're increasing the magnification or the image scale, is your telescope is more prone for vibration and all that. So any slight little movement on all that on the camera and all that will show up on the image on the laptop. So, like you say, the more you're doubling that magnification, the worse the vibration becomes. But I thought I would just give you an idea of how to do close-ups of moon and the planets with this. Alright, fantastic method, and it works extremely well. I thought, I hope this helps. And like I say, it basically attaches on the webcam, and once you got it focused, you should get it on your laptop screen, on shortcut, on the preview, and then you can just run it up, easy as all. What you're doing is you just need to capture a series of film footage. Now it just depends on how long you want to do it, but do it like for 30 to 40 seconds, maybe up to a minute long film. And all you're doing is just capturing as much frames as you can. And what you're doing is, you can get a live image of Saturn, for example, and it'll show you the detail and all that. But the key is to this particular astrophotography is to stack the images. Now the images have to be stacked. So what you're doing with stacking is basically you pick out the best sharpest image you've got per frame, and it's a program that I use called Registacks. Registacks is a program that you can pick out the best sharpest image, and then what you're doing with stacking is you're stenciling that best image you've got over the other images, and then what you're doing is you're stacking over each one to produce a final image. Now that image will be the sharpest image view possibly, and what you're doing with stacking is eliminates the atmospheric disturbance in the Earth's atmosphere and so forth. Alright, and that's what it does, and it gives you a single picture, and that single picture will, in result, will give you a much sharper image of Saturn, relieving much more details on the cloud belts, maybe the moons, and the ring structure. Alright, and that's what I use. Alright, I use Shortcut as my capturing software, alright, and then I use Registacks as my stacking to produce my final image of images of the planets and the moon. It works absolutely fantastic. Alright, and to start off with, to do that, it's easy, it's cheap to do, alright, it doesn't cost a lot of money to do it. Two of the program softwares are freeware, so they're free to download, and all you need is a camera adapter or some method or some means to try and attach the webcam to the scope itself. Now it could be anything, and believe it or not, people have, to attach the webcam, they use toilet roll or wrapped cardboard or something like that to try and get the webcam into the place of the scope itself, and people have done all sorts of stuff. But ideally my method is to get a camera adapter, a 1/4 inch webcam adapter to the main tube, because it's much more secure and all that, and you can get some really good images of planets and the moon. You can, it's really fantastic sort of start and a fantastic setup. However, the only downside is you cannot do deep sky objects with this particular method unless your camera is cooled and it enables to do exposure times where you can extend exposure times longer. Alright, but ideally webcams are usually mainly for lunar and planetary imaging. Alright, again, this is my setup. I usually set this on my 127 Maxwell telescope, which I use most of the time anyway for webcam imaging. Alright, and it's the best method of imaging to beginners. A good start as well. Alright, and you get some good results. The good thing about it is you don't have to be accurately pole aligned for this method, right? There's no need for pole alignment. So, in fact, you can actually do webcam imaging, believe it or not, if you've got no motor drive. Alright, you can actually use your slow motion controls, and you just fit the camera. Once you've got the object into view, you can just use these slow motion controls and let it, you can manually track the object. Right, and you can get some great images of the moon and planets. It works really well. But that's my method. But again, not good for deep sky imaging. Alright, and for deep sky imaging, you need to start delving into a DSLR or a CCD camera.